Hey guys, welcome to the stoichiometry calculations video. We're going to go through a sample problem and kind of try to explain it in another way just to help those of you who are still struggling kind of figure out where to start, where to go, what the pattern is. It really is a pattern, and it's kind of like a puzzle, and you can't just take everything at once. You got to take one piece at a time and put the pieces together, and eventually, you'll have a big picture, which is hopefully the right answer. So let's take a look at what we've got. Remember, the first thing that we need to do all the time, no matter what, for a stoichiometry problem is get a balanced chemical equation. So from the question, I'm going to look for key words like how many grams of water form. If water is being formed, that tells me that water must be a product. So he's going to be on the product side. And there's my arrow. And then what's going to be on the reactant side? I'm looking for keywords like reacted with. So hydrogen is reacted with excess oxygen. So that's going to look like hydrogen being reacted with oxygen. And I know that they're diatomic, so I have to have two. So I know a lot of you should probably go back to the reaction chemistry unit and watch those reaction videos, get comfortable with the wording, with the terminology, seeing that, okay, this is a synthesis reaction that would also help, put the pieces together. So little things like that. Okay, and then I'm just going to balance it. I'm going to put a 2 here and a 2 here, and that's going to be my 1. So now the stoic part, what's really important, I think, is knowing where you start and knowing where you're trying to go, what the question wants. So first thing I'm going to do is I'm going to figure out where I'm going to start. So that's always a number, units, and a substance. And I'm going to go into my chemical reaction as well and highlight the coefficient that I'll be using. So it's hydrogen gas, so he's my starting coefficient. I'll use that when I cross the mole bridge. And then it's also important to identify where we're going to end or what the question wants. And it wants how many grams of water. So that's what I'm going to be looking for. And here's my water. So I'm going to highlight that coefficient right there. And that'll get me to where I want to go. Okay, so the setup. Let's draw. I know that, hang on, I want a different color here. So I know that I'm always going to start with what's given. It's green. Green means go. So I'm going to do 30.7 liters of hydrogen. And I'm going to draw my chart. Okay, now here's the kind of different way that I want to show you guys. So with stoich, it's always the same process. You're going to start with whatever's given. In this case, it's liters. And your main goal all the time is to get to moles. So no matter where you start, you're going to start somewhere and you're going to go to moles. And then once you're at moles, you're going to cross the bridge. And then after you cross the bridge, you're going to go to whatever the question wants. In this case, it's, was it grams? So we're going to go to grams because that's what the question wants, and this is where we start. So this here now, this little kind of flow chart is going to be the top of my stoichiometry chart, and you'll see kind of how the units cancel out. But if it helps you to think, okay, I always go to moles, cross the bridge, go to what it wants. So as long as you can identify where to start, this pattern. It's always the same all the time, no matter what. What you start with to moles, cross the bridge to what it wants. Start, moles, bridge, once. Start, moles, bridge, once. Blah, blah, blah. Okay. So another thing is if I see liters, I know right away without hesitation that it's 22.4 liters of H2 for every 1 mole of H2. And if that's not something that you're comfortable with or that you know right away, you need to study it and you need to remember it. But you'll notice, so I started with liters and now I'm at moles, and that's what my flow chart said I should do. So hopefully I'm on the right track. Now I need to cross the bridge. Remember, crossing the bridge is the coefficients. So on the bottom goes where I started. I have H2 here, so I need to put H2 down there. And then, of course, it's going to be moles because we're crossing the mole bridge. And I already highlighted it in green, so I know that my 2 is going to go right there, 2 moles of H2. And then up top is going to go I'm crossing the bridge trying to get to what the question wants. So here's my coefficient, 2 moles of H2O, and that's what I want, so that's why it's on top. Want over start, red over green. Okay, so I'm not done yet. I went to liters, I got to moles, I crossed the bridge. Now I need to go to grams. So I know grams is going to go up top because it's what I want. And what is it grams of? Well, it's water, hopefully, because that's where we cross the bridge to. And where do we get grams from? I know right away. We get it from the periodic table. And if I look, oxygen 16, hydrogen's 1.01, so water is going to be 18.02 grams. And again, that's for every 1 mole of water. So the setup here and the process, it's always the same. You go to moles, you cross the bridge, and you go to what the question wants. Always, all the time, no matter what. So hopefully kind of seeing that will help you guys do these calculations a little bit more smoothly and kind of figure out the best place to start and how to get to what the question's looking for. So if you have any questions, just let me know, and where it is that you have questions so I can reiterate it or kind of say it in a different way. Just let me know what you need. All right, thanks guys.